Hi all. In this lecture we now consider some basic commands, data types and functions in R. And we start with the function C and the data frames. So the function C is this sort of a generic function which combines its argument. That means that if we use the function C, we can then construct, so for example, vectors with which are containing the real numbers, or we can construct a vector which contains some words or characters. The data frame, on the other hand, is this sort of a list of variables of same number of rows with the unique row names. So this is basically the function that is used to create our datasets. So here we have some examples of how to use the function C and then how to construct the data frame. So for example, we have defined here the variable y, which is now construct by using this function C, and there's this sort of arguments which are just real numbers, and then we end up having this sort of a vector C which has these real numbers. On the other hand, we could just construct this sort of other vector called x, again uses our C function, which in this case contains the word female 6 times and the male 6 times after that. And here we have used this sort of a repeat function to come up with this repetition of word female and male. And then the data frame is nothing but combining these y and x values, this sort of a dataset form, which is then given here with few observations missing out because of the slide ending. So if we look this sort of a thing in R, we can do it again. So that basically this code was created in this way, that we have first of all this sort of a y vector here, which is having this sort of elements, and if we use, for example, the length function, it gives us that this vector C, so this vector y is having 12 elements in it. And this time around, so this is like having for example, response variable with this sort of observed values in our dataset. So this would be close to that sort of a situation, that we have our variable in interest denoted by y, and then having this sort of numerical values. And then we have our vector x, which could be, for example, some sort of explanatory variable which is telling us that which observations are females and which are the males in our datasets. And again, we have used here the C function, but now we have used this sort of a repeat function here, which is 2 times basically, which is giving us this sort of a way. So if I put here repeat, for example, in a place of female, for example, number 3, it repeats the 3 6 times, and if I put here like a 4, it gives the 4 time, and so on. So this is a function which is repeating some argument given amount of times. And the data frame is then the way of creating these sort of datasets in R, or the classical way of creating the datasets in R. And in this case, for example, if we use now the data frame function with arguments being y and x, it now puts these 2 vectors as our column vectors in a dataset. So let's go it again, because I clicked in the wrong place, like this way. So this is our data now that which we could use to analyze this sort of a behavior of y vector with respect to this gender variable x. Now, besides these sort of a basic function like C and data frame, data is sometimes data is presented sometimes by using this sort of a tuple function, which is are like a modern take of data frames. In basic situations or for us, we really don't need that much with this tuple. We can use it, but it's pretty much the same thing as a data frames. However, I wanted to bring it here because this is something that you may start seeing very near future more often, that data frames are called as a tuples because it brings some new features to the data frames and some sense makes it more easier to work with the data frames. And then is this what is called as a list object, which are these sort of R objects which are containing the elements of different types. And many times when you are using the R and some function, it actually returns, the function is returning you this sort of a list object, so that the list can contain this sort of named elements, which can then can be a different kind of things like vectors or just one numbers or words or something like that. So for example, here we have an example where we have now used this tuple and list function. We need to install the library tuple in order to use this tuple. And if we use this sort of a function tuple with a y and x as an argument and call it that as a data, then our data looks like this, and it's pretty much same as a data frame, except that there's some extra information and so on. And then we have here created what is called as a list object named as a data info, which is now in a way the list, that so that there's arguments or the elements like x and y, which are then assigned to be as original variables x and y. And then we have this sort of a named element mean, which in this case is equal to the mean of y vector, and a name element called sample size, which is actually the number of rows in a data set. So if we look these sort of things in how we use it then here in R. So we first, if we use the tuple, we need to install the library tuple first, and then we can start using it. And in this case, if we define the dataset by using this tuple function, our dataset looks like this. So it has nothing really changed, and everything works as similarly as using this sort of a data frames. Most often during this course we use just data frame because it's a classic way of creating datasets in R and store the data in R. However, this list is important of objects in R in a sense that if you start writing your own function, then most probable that you will end up returning your result in a list form. So in that sense, that's important thing to do. And here we have this sort of we have made this sort of a list called data info, which is now having this sort of a name elements as x, y, mean and sample size. So I can now point to the for example, the values of x by putting this sort of a dollar sign and then x, it gives me the values of x in this list. And same if I use, for example, data info and dollar sign and mean, then it returns me this sample mean of y vector, how it was here as defined. However, if we change the definition of these things, for example, to mean to x, then sorry, that doesn't really make any sense, so I cannot do that. But for example, use the function length to the x, and then we look the data info. It's just the number of elements in an x vector. So what we used here in this list object, we used, for example, this sort of a basic function, which is nothing but the arithmetic mean of y vector. So if we take the y, which has this sort of a values, we take the sum of y's, which is a value like that, and divide it by number of observation, we get an arithmetic mean, which can be calculated simply by in this way. Of course, we have this sort of a simple function as like minimum, which gives the the medium, which gives the medium of the vector y, or whatever vector we give as an argument, maximum, minimum, and things like that. So these sort of our functions, they are really basic functions in a way that we use those always when we do some calculation and handling of data. So that's pretty much gives us now the idea of what is the list. This table thing was only given here so that you would then understand that if you start to see the data sets formed by using this sort of table library, then it's nothing but data frames, which is a classical way of pretty much the same as using the data frames, which is a classical way to create and store the data sets in R. So once we have covered this really basic stuff, we can then look maybe some useful function for handling the vectors, which are like the length of the vector, replicates of the values, sequence operation which generates regular sequence, and append, for example, which adds elements to the vector. These sort of things we always need when we are creating maybe new variables or new data sets where we need to calculate some sort of things. If we have to put some new variables to the data sets and so on. So for example, the length of the x, we already looked that. It can have a value like it gives the number of elements in an x vector. Then we have this sort of a repeat function, and in this case, for example, this notation here, by the way, it means that R is printing the values from 1 to 4, and so if I start here like an integer 6 to 23, then we get this sort of a values vector of for integers from 6 to 23, sorry. And if we use, so the repeat is now repeating this 1 to 4 2 times, and there was like said in the first time repeating 2 times. But if we have this sort of a sequence or vector of values, then we can repeat it 2 times. So if I put here like a x, then it's repeating the x 2 times. And if we use this sort of a repeat and each element is asked to repeat in 2 times, then it gives us the result like that. So repeating each value of x vector like 4 times would give us this sort of a data set or the vector. And so this repeat function is so very much a useful function for creating this sort of a variables where some values are appearing more than once. And then there's this sort of a sequence which gives us the values from different values for values from starting point to the end point by jumps defined by this by argument. So if I run this line, we get this sort of a sequence like or the vector where the starting point is 0.5, then comes 0.6, 0.7 all the way to the 1.5. And that is often needed and used. We may use the sequence function without actually giving these names for these arguments, and this is like creating the integer values from 1 to 10. That is, starting point is 1, end point is basically to 10, and then by 1 jumps we are creating the values. Well, kind of same. What is this sort of a function that is often needed is which is really missing our list is sort of a sort function, which is basically sorting out the values in a increasing order, or sorting the values decreasing order if we put this sort of argument. So these sort of things are also needed quite often when handling with the vectors. Then I want to also show this sort of append function, which is, for example, if we have an x value here and then we use the append x, and for example let's put there a value a male. Sorry, let's put here now. Then it puts some extra male value in this to the end as a new element to the vector x. And I could of course call this as for example the vector w, which would then give us this sort of. So there's now one extra male value in our new vector, like here. And in this example, what we have here done, so that sometimes we may have a situation that we want to repeat or do some calculation as long as this something is holding on, and when we proceed with our course we end up using this sort of a for loops, for example. But here in this example it's just to show that if we start to see this sort of a z variable, or which ends up being vector, and give it to the value 0 first, and then we used the append function so that for each case when this sort of argument I is running from 1 to 5, we append to the c vector this value I, and then point it again to this c vector. We end up having values 0, 1, 2, 3, 4, 5 in our z vector. So if you want to, for example, repeatedly do some sort of things for each row of the data set, then you may end up using this sort of a for function if there's no other way to do it, and sometimes you may want to calculate from each row of the data set something. Then if you want to store those values what you are calculating from your each row, you may first kind of start a new variable or define a new variable, and into that new variable you place your calculations. So that's the very starting point for this course, and function that is are needed to get started. Most important one is obviously this C function. You use it all the time if you use the R. And the data frames, it's important to understand the data sets are usually stored in a data frame form, and list is this sort of a quite generic R object which contains the element of different types, so it's very flexible R object. And then we can look some example. So this is pretty much just a simple example of how to write the data in if you have to do it manually. And of course, when we now move on from this example 1.1, then we move to the situation where we kind of read the datasets in. If you have a dataset, for example, in a text form or Excel form, how we should read the data into the R. But anyway, let's start doing this one. So this is sort of a biodiesel study where we wanted to produce the canola oil. Or the biodiesel study where the interest was to see where is our yield level is going on with respect to the axis, like a time, temperature, and amount of methanol. And here the data set already in it is sort of a dataset form, so that each row is our experiment, and then each column is giving us the values for the variables. So we should start with defining these sort of variables in our time, temperature, and methanol and yield. Put these sort of values in there, in R, and then create this sort of a data frame. That is basically what is asked in a question 1. Create a data frame object with the variables time, temperature, methanol, and yield. And once we have done this, then we can create a new variable ratio, which is nothing but a yield divided by the methanol, and then calculate some simple things for this ratio variable. And after that, once we have done that, then we can we have learned our first lesson about the R. So let's do the calculations here. So I start by just looking at the data set first and try to come up with these values. So we needed to now create this first value, which was a time variable, and it has this sort of a values like 15 6 time, and then comes the value 36 time, and then comes to the 45, I guess 6 time. No, there's something wrong. 1 2 3, there's a 4 time, sorry, 7 times 30, and then 6 times 45. So let's do that. So we can use now the function C and maybe the repeat function so that we repeat the 15 the 6th time, and we put together again to repeat 37 time, and the last one was that there was a 45 in a 6th time. And using this sort of a C function where we combine together this repeat result of these repeat functions, we get in the end our time variable like this. And then if we look at the second variable, which was the temperature, temp, it has this sort of values like 240, 240 and so on. Well, I don't know how to start doing this. There's one option is to just write each element and not worry too much. And the second way is that if I look these values, there's quite often a value 240. So why not we just create, for example, this sort of a vector which is having the values 240 like 19 times. So this is really our temperature starting point. And now this is something that we will look more carefully in next examples or in upcoming lectures, is that in R, what is R in good at is that there's a quite simple ways to point out for the elements of vector, to point out to the elements of the data sets. And in this case, for example, we obviously need to change the value 4th, 5th and 6th to the values 255, 270, 270. So for example, if we now take here the temperature, and then we use this sort of brackets, and we put here, for example, the number 4, and look the run line, then it gives us the 4th argument or the 4th element in our temp vector. And if I put here to 4 to 6 like this, it gives us the 4th, 5th and 6th elements from our vector temp. And what is now great thing about R is that you can take these sort of elements and change the values by simply pointing to these elements and then give them the new values. For example, in this case, I could give the values 250, and what was the other values? Sorry, 55 and then 277. 270 and 270. So these three values are now placed to the temp vector in a place of 4th, 5th and 6th element. So if I do here the run line or selection, and if we now look the temp vector, it has this sort of a values. So this is very important thing what is happening here, and we will return many times for this thing, for pointing out to some elements or picking up some elements from the datasets and then maybe changing the value or doing something else. So we can start creating our temp again, so that we have now done this and then for example to 9 to 12 we have this sort of a values like 255. So let me do that. It is easy to do now. This is, of course, we could have just produced this temp vector even quicker if we have just used use the C vector and put these values together, but this is a good way of start understanding how the R is working, how this way of pointing out to the elements, how it is working. And so here we have a 255 all the way to these things. So why not put it like this way? So this means that it is repeating this value for all these elements to the 9 to 12. So this gives us the, sorry, I was in the wrong place. Let's do it this way now. So our temp now looks like this. And now we have to think about the last values which are there in a wrong in this case. So 13 is again 270, 17, 18, 19. So let's do that. And hopefully we learn something about this thing. So now I take a copy of this row because we are really needing it. So now we need to put on places in this temp vector in the 13 element we should put value 270, and then on the elements 17, 18 and 19 we should put these sort of values. So if I now pointing out here the 17 to 19 like this, and then using the C vector here inside the brackets so that there's 13 and then 17 to 18, I'm having this sort of a vector. And when I'm putting it in here to this inside the bracket with the temp vector, then it picks up these elements from this temp vector, like here. Now, and I can then place new values for those places like 270 going to the 13th place, which was asked, and then, sorry, what was the values? 255 and 277, 255, 270, and now. So hopefully, if we now look at the temp vector here, it should now be the right one what was asked. We do it in some sense a hard way. Of course, we are doing this data set in a hard way anyway in this example, but I hope that you now learn that there's this sort of a bracket way of pointing to the elements of the vectors, and we can change those values in the way that we have now demonstrated. So that is basically our second variable now, and then comes to our third variable, which is methanol. And well, it has also these sort of values that seems to be going all the way around. I don't know what to do with this one. Maybe we should just write these values and be happy that we have these sort of values available, and do it in this way, and rather than just trying to make some clever function, because it seems to be taking maybe more time than than to use some other methods. So let me define this sort of a variable called methanol, and if we now go to the back to the data set, and then we can just use the C function, which gives us that first element is 1, second element is 1.5, third element is 2, then comes to the 1, what else? And if we then continue with the 1, 2, 1.5, 1.5, 1.5, 2, 1.5, 1, 1.5, 2, 1.5, 1, and 2. So obviously you immediately notice that this is not really the nice thing to do, and it would be maybe better to get the data in some other form first, and then start to bring it into the R in some way, and then use it then the data in R for this data analysis, and rather than start writing these sort of simple values like this. However, we will of course go next to the topic of how to bring the dataset in if you have a dataset, for example, in Excel form or some other form. So let us now lastly do this yield variable, and then we can look to other topics, and if I so go here and I little bit make it more bigger so that it is easier for me to read, then I can just put these yield values here similarly that they are like 1.5, 3.2, 3.8, 2.2, 8.9, and so on. So if you are not hurry, you can do it this way. And once we have done it now in this way, this is obviously the last time we during this course start to write the datasets in this form. By the way, there's a big value 60. Okay, there's other values too, 4.4, 16.5, 24.5, 62.8, 96.4, and the last one here is a 102, like this. So if we finally have hopefully able to read the data like this. So this is our basically our question A, and we have all these variables in a vector form now, and we can then create a data set. We can give this data set some name. What name would be the good one? This is a biodiesel study, so I put here like this way. So if we now use the data frame function and we put there the variables time, temperature, methanol, and yield, then we have our dataset which was asked in this question. And if everything went rightly, we should have the right values here. If I made a mistake some point, well, that's really an option when we are handling this data by hand, but other way around, it should be we can then of course to fix the values if there's some problem. However, then the second question, or the question B, was that we were asked to calculate or create a new variable called ratio, which is what was the ratio with the yield and the level of the methanol. And so if we go here, we should create a new variable like this way, then we can calculate the sum and the sample mean, the sample median of the variable ratio, and create a list object which contains those values. Well, let's do that. So the first thing is to do the ratio variable. Well, it's most easiest way to do. So we can call it as a ratio, which is nothing but a yield divided by methanol. That's a ratio variable. And it would be a good idea to put it in our data set. So I could do this way, so that I take the data frame function again, I take our biodiesel dataset and I put this ratio variable there after all the variables in biodiesel dataset, and I call it again this new dataset again as a biodiesel dataset. So we end up having now the dataset where we have also include the new variable ratio. And once we have done that, we can then, for example, even to remove the ratio variable by using this sort of a rm function. So I mean, if I write here now ratio, then I put the function rm ratio, and if we now try to find the ratio, it's not anymore there. However, in our data set, you can still find the ratio here in our dataset biodiesel. So we did not remove this ratio variable our dataset biodiesel by simply when we removed actually the vector ratio. And sometimes you have to be careful that if you have some vector which is having the same name as some column in data frames, that which one you really want to point out, which one you want to remove, or which one you want to make some adjustment. You have to be careful when you are dealing these sort of things, that the same variable or vector is in different places. Anyway, so that there was now questions in C that we were asked to calculate the sum and the mean, sample mean and the sample median from this ratio variable, and put those values in the list. And I could call it, for example, that it's the name of the list would be like a biodiesel some information. So this sort of a variable names where there are dot like here, it is acceptable in R. So I could now create this sort of a list where the first element could be, for example, called sum, which is nothing but a sum of the variable ratio, which can be found in our biodiesel dataset, like this way. And then we could have a mean, which is nothing but a sample mean, of this ratio. So we use the function mean here to calculate the sample mean. And then we could have a, for example, median, which could be, for example, or which is just the sample median of this ratio variable. And then we should have a one parenthesis there to make sure that everything is fine. So this should now produce this sort of PyDiesel named list object, which has these sort of name elements like sum, mean, and median. And then if we run this line, sorry, we need to go here, run this line, and if we now looked up this sort of what is this PyDiesel info object, what sort of values it has these sort of elements sum, mean, and median, and the values are the ones we were able to obtain by using the sum function, mean function, and median function. And now you can then get the value, for example, the mean by using this name of the object, which is a PyDiesel info, and then use the dollar sign, and then the name of the element in our list, for example, to me. So this would give us the value of the mean in our ratio variable. Of course, I'm not so sure that these sort of names are very formative, because there's maybe we should have called this as a info for ratio, ratio info, or something like that. Anyway, now we have done these sort of things which were asked to do in our example 1.1, and this could be just the end of our first video lecture of this basic stuff. So you should now be able to create or to use the vector C. You should now know what is the data frame. You should now know what is the list, and maybe some understanding about these basic simple functions which could be used to form vectors. And then there could be these sort of simple functions like mean, sum, and so on, minimum, maximum, which are just calculating some things from our given vector. And then from now on, we then proceed from next lecture video about how to read the already existing dataset to the R, and how to do some transformation to the datasets which we have already brought into the R.